point is, the reason you're reading about it is because of the lowered heart rate. Good, 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 good. All right. Now, I want to just talk, and again, I'm trying to hit this as many different ways as I can. For those of you that aren't visual and you like text versus visual, this is what it would look like texty-wise. Now look at this. What's the chance we got our non-lowered heart rate data, assuming caffeine doesn't lower heart rate? Well, don't those two things agree with each other? That agree. We got non-lower data, caffeine doesn't lower heart rate. That agrees with each other, yes? Shouldn't that probability be high? It should be high, because that means it's still on the curve, in the meat of the curve, which is the normal 95% confidence interval. We haven't moved outside of that interval at all. So when p-values are high, it means the opposite of what your research hypothesis, essentially it means the opposite of what your research hypothesis is saying. You had a null hypothesis. You got data that essentially agrees with that null hypothesis, therefore nothing to talk about. We took caffeine, our heart rate went up. Or better said, we took caffeine and our heart rate didn't go down. Now realize that's not the opposite of saying our heart rate went up, because it could stay the same. Yes, there's three things. It could go down, it could go up, or it could stay the same. So when you say non-lowered, that means either stayed the same or went up. And the same thing can be said, of course, the same thing could be said for the maximal exercise one. We got non-lowered heart rate data, and we went into the study assuming that caffeine wasn't going to lower heart rate data. So once again it agreed. Once again it agreed. That's why you see back on this curve these two blue asterisks. I guess that's blue. These two blue asterisks right here. The blue asterisks mean nothing unusual happened. Whatever happened, you were expecting to happen. Oh good, and that's why I hit it both ways. Who likes the picture better than the text? But just a show of hands, text better than the picture? Okay, see, this is why I do it both ways. I do it both ways to hopefully hit as many people. If you think of a third way that would make more sense, let me know. I'll work it on the PowerPoint too. But I thought of the graph a couple years ago. Just FYI, this section, if you want to call this a section, doesn't exist in stat textbooks. There's no such thing as intro to hypothesis testing in stat textbooks. They mix this in with the tests themselves. About 10 years ago, I realized that's a terrible, terrible idea. Because these p-values become mysterious. They become misunderstood. It's better to have an entire section devoted just to them and their limitations, which is why this section came into existence. All right. Here's the big idea we'll leave with today. When you get a big p-value, and we're going to talk about big p-values being something over 5% because that's generally the industry standard. I'm not saying it's perfect. I'm not saying we should always use 5%. We'll analyze that in this class too. But 5% is industry standard. Nothing unusual has happened. Whatever effect you're studying has no effect, allegedly. You're trying to see the caffeine lowers heart rate, you get a p-value. Well, I can't say caffeine lowers heart rate because it looks like it doesn't lower heart rate. Big p-values imply the two pieces of your conditional probability. This is for the two people that like to text. Steph, and who else like to text? Steph and Amaya. What do those two pieces of the conditional do? Agree or disagree? Very nice. They agree. You got non-lowered data. We were expecting non-lowered data. They agree with each other. You're in the confidence interval of agreement, if you will. Good. Very good. Very good. And there's an example of it. There's an example of it right there. That's what a big p-value means. A big p-value, you're not going to read about them very often in a study, which is also unfortunate. There's another article I just read. You sent it to me. That article you just sent me about 3 weeks ago. The lack of true negative results in the research versus the plethora of false positive results in the research. True negatives aren't very often reported on. Well, they should be. They're just as valid as a true positive in many ways. But more on that later though. Again, large p-values, I just want to talk again. Your data has fallen within what if you get a big p-value? 95%. Good! A 95% confidence interval is a perfect answer. I heard somebody say 2 standard deviations. I love that too. I love that, thank you. Or maybe 2.575. 99% confident. Up to you, Carly. Up to you. P-value tells you. The p-value tells you that. That's good. Now, is anybody a little bit peeved at the fact that that graph didn't have a normal confidence interval on it? It looked like it was all shoved to one side. Good. Because wait, I saw that. I wasn't saying anything. Yeah, not all of them are your traditional two-sided, two-tailed confidence intervals. We'll more on that on Tuesday when we come back together. Sometimes they're one-sided intervals, and there's a reason for that, a very good reason for that, in fact. So, and I just talked about this, large p-values are generally those bigger than 5%. That's usually the cutoff. I'm not saying it's always right, I'm saying that's what it usually is. Fair so far? All right, and one last one, the big idea for small p-values. You'll notice an exact opposite in every single result from this. It's a great place to stop for the day. Small p-values imply, ladies that like to text, the two pieces do what to each other? In small p-values, they disagree. You've got lowered heart rate data, but you were going in assuming caffeine wasn't going to lower. That's a contradiction. That's a, yes? Yes, good. Disagreement. You got disagreement when you get a small p-value. Disagreement says, ooh, what just caused that? Take another look at what caused that. What in the caffeine? Maybe it was VO2. I love that, by the way, Julian. Thank you. And the very last slide, to wrap it up, you had a measurable effect. Where are you now if you're a small p-value? Outside of your confidence interval, outside of your deviations of acceptance. Generally less than? 5%. Good. Well, I shouldn't say. Good answer. I'm not saying I agree with it all the time. We'll talk more about why sometimes we don't like 5% later in the class. But right now, we'll stick with 5% because that's what you're going to see. Have a great weekend. We'll see you guys on Tuesday. Caitlin, what was that question you had about your quiz earlier?